Hey guys, Josh Starnes. This project's on EasyRobot.com and also JoshStarnesLabs.com coming soon. And I just want to show you here, this is the bottom of the beer robot, by the way. And this was kind of a little tub and a big gap of around 1.5 inches all the way around this. And this really needed to be insulated, and I had to cut off the inside liner that was sticking out here because the portion that was sticking out would have been a pretty much a large heat sink, basically to let heat into the chilled section because it was one continuous piece. So I had to cut that off. I actually cut it off below the level of this heat sink, and then filled all the way around in the previous video, and then continue to go around in a spiral. Now, I only wanted it to be about this thick, but it ended up going all the way out to here. Okay, it was just ridiculous. And I used my handy dandy steak knife and just kind of carved it. You actually see the carvings here, just like a pie or a cake. And then after dividing it up in about 8 slices, I wedged the knife up under it and kind of turned it sideways back and forth like that. You can kind of see the marks and just kind of pry those pieces out. From there I used the Dremel, which is right here. Okay, used actually a carbide bit on it. Kind of looks almost like a CNC bit. Basically, that's went just like this, just back and forth, just a little bit at a time, until eventually I had this flat spot. Okay, then actually around the edges just went like this. Okay, that's how it's kind of got all scratched up, and that's why the edges from right here aren't as neat, and obviously this is like really smooth. So that's how I did that. I just went real slow back and forth, probably 1/4 inch at a time, until I got the appropriate height. I just cut this out. It's actually a little bit too large on accident, but that's fine. Just to give you an idea here, this is all the chunks that I pulled out. It's kind of just like a pie. Alright, so there's a lot of it actually had to get pulled out to be able to get down to this point. Even now, it's still 1.5 inches, 2 inches right there, and once it gets past the heat sink, it is about 3 inches over here on the edges, and about 1 inch down the length of the body. Alright, so I'm going to show you how this heatsink fits in here. Pardon my workspace, I'm not working in my little office right now. I don't know why, I guess that's kind of like being downstairs sometimes. Anyway, this is the heat transition block, solid aluminum. Okay, pelters up under this. This is just kind of a insulating foam around it. I'll actually probably put a little bit more around here, the edges. And that connects to the inside heatsink, okay, to pull heat through this, through the peltier, and then out the hot side. And that's how it fits right there. Actually, I'm pretty sure, yeah. It's kind of floating right now, but if I push it just a little bit, it doesn't take much to be directly up against the heatsink on the inside. So, but I want it to be kind of snug because I want no air to be able to get to this, or to this, sorry I touched it with my right hand, to this block. I want to try to block that out. I might actually silicone around this edge possibly, so that when I bolt this down, air can't get to it. Now what I'm going to have to do is air has to get to this, and this little notch right here, I'm not going to cut it. Okay, matter of fact, this is the front. That's probably where I'm going to put some navigation stuff. So that being said, probably this area here and this area here I will use for some 5 1/4 inch fans. Pattern drill this just like I did the inside grate, just a smaller drill bit probably. That way airflow can come out one side, blow through the, be pulled through this heatsink, and then exit like the other side or something like that. Or I could just put one on each side. Kind of doesn't matter really how I decide to do that. Anyway, so just a tiny update. I'm going to go ahead and upload this. And, oh, just actually, before I do that, I was going to show you something. The top of the container, I still had this. This is the original blower that actually cooled this. It was mounted to the side, and as it blew, it just kind of pushed air through the heatsink. Works okay, but in this configuration, in this placement, it's not going to work. Okay, but I would hate to, for this little doodad to go to waste. It does seem to be a nice thing to have. So what I did is, I got to looking how I was going to put the lids on. Okay, and I'm just going to show you here. This is a small lid. This is the lid to the one on the inside. Okay, so obviously it fits the inside too as well. Well, what I thought about doing is taking this one, okay, cutting the flange off right here, and gluing it to the inside of this one. That way it has not one overlapping seal, but two overlapping seals before it gets to the inside area. So that goes up and then up over again and then into the actual area where it's chilled. Now my idea here was, if I can just take this, and not necessarily to this right here, I mean, I'm probably going to have this built out or something, but probably about yay right there, a couple inches from the top of that. That way this is dead center over the top of the chiller section, and it's going to spin, and what happens is that pulls air up and then pushes out the sides and won't force it back down. That'll promote circulation from the top. That way not all the work is relying on the fan. It's actually under a grate, which is a little bit of resistance. This won't have any resistance. So I thought I would use this to kind of help the fan at the bottom move the air around. That's the number one factor there, is air movement, to be able to cool everything. Without the air moving, it would take a really long time for it to cool off. As a matter of fact, the manufacturer indicated it takes a little over 3 hours to get down to temperature, which is 38 degrees difference of ambient temperature, inside just a cooler with no air moving. So, it's going to take a really long time if there's not air moving around. So that's why I was thinking about using this. I also have a smaller version of this too as well, just slightly smaller. There's black. This one I do believe moves more air because it was made for the hot side. I might paint it or something like that, make it kind of blend in, make it look more professional. But basically the idea here is to put this on the inside of this, okay? See how you got that double? This is the outside edge. You got a groove there, goes inside, and another groove, and then we have a seal. I can put some weather stripping probably right down the middle of that, so it's up against this and this, so you have a double seal. That was my idea. If anybody has any objections to that or better ideas, please let me know. I haven't made a whole lot of refrigeration units. I'm basing this all off of things I've just looked up online and things I've seen from professional, super large refrigeration units that were made of steel and had rubber seals and stuff like that. So, but I know just because it's professional doesn't mean it was the best way to do it. So I'm going to go ahead and upload this video, and you can kind of see, get an idea of placement for that. And you guys have a great day. Again, this is Josh Starnes, joshstarneslabs.com or easyrobot.com. You will be able to see this project. Have a great day.